In this video I'm looking at the solution to question 6 of the June 2011 Edexcel D1 paper, and the topic of this question is Dijkstra's algorithm. The question talks about figure 6, which is given to us in the paper, and it says it shows a network of cycle tracks. The number on each of the arcs gives the length in kilometers of that track. We're asked in part A of the question to use Dijkstra's algorithm to find the shortest path from A to H and stating our route and its length. Part B, we're asked to explain how we actually determined the shortest route from our label diagram. And then a secondary part of the question says that the track from E to H is now closed and cannot be used, so we then need to find the shortest route in that situation. Well, in the answer booklet there is a standard diagram for us to fill out for Dijkstra's algorithm. So this is one where we have to put in labeling with working values on each of the nodes to start off with. Now we're starting at A, so its working value is going to be 0, and this will then be the first point to be labeled, and we'll have a final value of 0. We then work forward from there, going to each of the other nodes that can be reached from that point that we've just labeled. So from A we can reach B, and that would have then a working value of 25, C 11, and D 27. So the algorithm then says, looking at the nodes which have not yet got their final label, so all of them, B, C and D in this case, look at the smallest of those, which is C, and that becomes the next point, the second point to be labeled, and its working value, or its final value rather, is 11. We then go round this procedure in a loop. So from C that we've just labeled, we look at all the points that can be reached. Now from C we can reach B, and that will give us a total of 11 plus 10, so 21. Now therefore the working label on B becomes 21. We can reach E, and that would have a value of 51, and also D, so 11 plus 13 is 24. Now you don't necessarily need to cross out the old values, but make it clear that they are changing. If you do cross them out, make sure that the numbers underneath can be read. So we then look at all of the values that have got their temporary labels and not had a final value, so that's B, E and D, and we can see that the smallest of those is B, so that becomes the third point to be labelled, and its final value 21. Okay, from B we can get to G, giving us a value of 64 for G, and we can also get to E, giving a value of 21 plus 29, which is 50. The smallest one that we have is down at the bottom here at D. So remember, you're not just looking at the ones that we've just been talking about, G and E. You must look at all those that haven't yet got their final label. So D is the one which is next in the list, and that becomes the fourth point to be labelled with a value of 24. Well, from that one we can only go forward to F with a value of 39, and that now is the smallest one of the three that haven't been labelled yet. So F becomes the fifth point to be labelled with a value 39, and from there we can work forward. From F we can get to E. 39 plus 10 is 49, and 39 plus 53 to get to H gives a value of 92. So the smallest of these now is E, so that's the sixth point to be labelled with a final value of 49. Working forward from there to G gives us 59, and to H from E, 49 plus 30 is 79. So the smallest of these is now G, which becomes the 7th point with a value of 59. And finally then, from that point, working forward, 59 plus 12 is 71. And that becomes the last point, the final point, 8, to be given its label of 71. Right, now we need to work out our shortest route. We can see that it's going to have a length of 71 kilometers, and to work out what its path is, we work backwards from H and subtracting the length of an arc. For example, the 12 here, 71 minus 12 is 59. So because 71 minus 12 is equal to 59, in other words, the difference between the final values is equal to the length of the arc, or the weight on the arc, then that is an arc on the shortest path. If we looked at, for example, H to F, 71 minus 53 is not equal to the 39 at F, so that is not part of the path. So continuing in that fashion, we find that the path comes down from G to E, and then F, long to D, up here to C, and finally finishes off from A to C. So in each case, the number of the final values, the difference between the final values rather, is equal to the weight of the arc. So our path is A, C, D, F, E, G, H, and it has a length of 71 kilometers. You need to then put a statement in of how that is done. So something along the lines of work backwards from H and include arc. We often describe it as a sort of general arc XY if the value of X minus the value of Y is equal to the weight of the arc. In the final part of the question, we're told that we can't use the path from E to F. So this path here is going to be ruled out. Well, we can see that the path from E to H is still going to be the shortest path. Remember that there's something called Bellman's principle, which says that part of a shortest path is itself the shortest. So that from E to H, we're still going to do E, G, H. So in part C, the final part is E, G, H. So we've got to work out what's the shortest path to get us from A to E without using F to G. So obviously we can't come the route that we've got there, and we'll see quite easily then that the route is from A to C to B. And from A to C, and then from 11 up to, so that's going from A to C, giving us 11. 11 plus 10 is 21, and then from the 21 plus 29 is 50. So instead of the 49 there, we've now got 50 to get us from A to E. So it goes A, C, B, E, G, H. and the length, instead of 71 kilometers, is going to be an extra 1, so the length is now equal to 72 kilometers. The marking for the question was as follows. There's, in the first part of the question, using the table, an M1 mark for showing basically replacements being done, A1 for getting the first 4 parts, A to D, correct, a second mark for getting E and F correct, and then a third A1 mark for getting G and H correct. The route itself is just an A mark, and that would be the correct answer only. So you'd only get that if you'd actually got the right, as you no follow-through marks there, whereas in the marks beforehand, these were follow-through marks if you'd made an error. And the 71 kilometers was an A1, and again a follow-through mark, so if you had made an error in your table, then your length that you had got on your table would be given the credit. An explanation of how the route was found. I was given 2 marks depending on the clarity of the explanation. Then B1 or B2 was awarded. And finally, 2 marks, B1 and B1 for part C of the question. Well, that's the end of the solution to that question. You can find solutions to other questions at www.furthermaths.org.uk.